All right. Hello, Jina. Hello, Nanya. Okay. So again, good afternoon to everybody. What we are going to start today, we are going to talk about non-linear functions and look at some of the interesting properties of non-linear functions that we need to deal with or that we need to be aware of. Okay. So, can somebody tell me what is going to be a starting point for you guys if somebody has to describe what is a non-linear function? So, careful. Come from this side. That side is wet.
This side?
Yeah, come from this side. It should be a little better. I have tried putting the epoxy and it is still drying up. Should be fine. Don't go that side, Arush. That side might be a little sticky. Okay. So Saranya, we have Vivan, Ria, Jana, Dev, Ritika, Samriddhi, and here in the classroom we have Arush and David. So we are going to learn non-linear functions. So I want to understand from you guys what would be your understanding around what is a non-linear function. What do you mean by that?
Function that has more than one derivative, kind of.
More than one?
A function with its degree higher than one.
Okay. Let's see what is Ananya's definition of non-linear function.
Like something that's curved.
That is curved. Okay. Any other definition?
Any function that isn't only a straight line.
Okay. Something, yeah, like Ananya said, something that is a curve. Yeah. Okay.
No, like
Say.
you can. Wait, I need to confirm something.
Okay. Ria, Jena, Dev, Samriddhi, do you guys have different way of looking at it? When I say non-linear function, what do you mean?
Hi,
Yeah.
sir.
Lavita. Dev, go ahead.
Oh, I think it's like when the rate of change is changing at like an increasing rate instead of a constant rate.
Okay.
To add on what I said before, as long as it's more than one straight line, then it's not linear.
Okay. So, different ways to describe it, and all of you were right with your definition of it. One way is, I'll start with linear and non-linear, right? Like accurate and non-accurate, the way we say, right? Something that is accurate, we are calling it accurate. Something that is not, we are saying non-accurate. Same way, linear or non-linear. So linear function is a linear function, and we know why we are calling it linear function. And something which is not linear is a non-linear function. Now, linear function when you're talking about, there's another definition that I heard from you guys. That is something that is not giving one line. So if you look at, this is a one line. If you are looking at a curve, it is made of all these small lines put together, forming this curve. Or other definition I heard from you guys is when the rate of change is not constant. If I'm talking about a linear function or a linear equation, let's say y equal to function of x, which is 2x plus 5, let's say. So here y is changing at a constant rate against the change of x, yeah, which we call a slope or whatever you call it. Here you're talking about a function y as f of x, which is x squared minus 2. So here, with every change of x, y is changing at a different rate. It's not changing at a constant rate. And that is how we all land in a curve-like situation. Yeah? Does that make sense? I did not say anything new. I just borrowed concept from you all. Okay? So, to begin with, a linear function. Again, I have told this so many times, I will repeat myself one more time. Whenever I am talking about linear function or linear equation, I always focus on this part of the word, which says line. if I have a linear function or linear equation, I mean linear function, linear equation we can use interchangeably. Why? Because if I can write this like this, y equal to 3x minus 9, I'm saying this is a linear equation. I'm changing this y to function of x. I'm saying y is function of x, which is equal to 3x minus 9. Now, since I described y as a function of x based on this condition, I'm calling it a function. But apparently, the underlying concept remains the same. It's the same thing. Linear function or equation we can use interchangeably. I'm not introducing a new variable y. I'm saying something which is a function of x is based on this relationship. So I'm calling this a function. If I replace this with a y, I'm calling this an equation. So be it a function or equation, it would not change the conceptual layout of the things much. Yeah? So when I'm saying linear function or linear equation, essentially I'm hinting at this word line, which is hidden within linear. Something that helps us draw a straight line, that is what is a linear equation or linear function. If it is not linear, I will call it non-linear. And then what first difference it will make for all of us is it will not draw a straight line. Yeah. Now, linear function could be coming either in the form of something which is a non-linear equation, or which is a derivative of a non-linear equation, or it could be something when a function is comprised of multiple functions within it, which we call as, when a function is comprised of multiple functions, what is that called? Composite functions. Yeah. So if I say, let's say there is a function of x which is 3x minus 9, and function of g is function of f of x. Okay. So whatever comes from here, that becomes an input for this guy, and then we derive it. So when you're talking about a scenario when your function is comprised of multiple functions underneath, that is what is called a composite function. Is everybody with me so far? Okay. So now let's start muddling the water a little bit more. So linear function, non-linear function, composite function, these are just the basic definitions that we'll come across. We'll look at how that relates to each other and how do we apply them for dealing with them. Nikhil? Okay. So we just started talking about linear function, non-linear function, composite function, and what is the difference between them conceptually. Now let's look at one problem real quick to see what does it mean to us, and then we'll go into something interesting. I mean, today I had plan of not teaching you guys anything. Rather, I wanted to actually play with something which is called movement of graph. Transformations, yeah. And look at the underlying concept that stays with us a little longer. So let me do one thing first. I will quickly touch upon one of the composite function and then see how do we relate to that and how do we evaluate a situation which is called a composite function. So I have a problem which says, and I don't have a problem, I have found out a problem for you guys. It says, let's say function of x is equal to 5 to the power x, and g of x is equal to x squared plus 1. What is the value of g of f of 1 minus 2. So here, this is a classic example of a composite function where this is comprised of this function and this function both, and whatever comes out of this function becomes an input to the second function. Yeah.
It's 10.
Okay. So can you guys help me evaluate this one and tell me what the value of this would be? I got one answer and I would not take it on face value. I will let everybody
Last word.
deal with it.
25.
So what did you say?
Because 5 minus 2.
Okay, yes, Nikhil.
I have 1 minus 2.
I think it's 5 to the power of x,
Oh, I thought it was g of x
x
plus
plus 2 plus 3. No, sorry, plus 5.
So tell me what the answer would be before I start bugging you for telling me the approach that you took for deriving it.
I got 5 to the power of x plus 2 plus 5.
I have some problem that comes with age. I don't feel comfortable when I don't see the kids using pen and paper. Okay, I will hold it. Let's see what is Dave's answer. Yes, Dave.
I got 10.
You got 10. How about Vishal?
I got 10.
You also got 10. Okay. Whether you got 10 or you did not get 10, I would assume everybody else to review their answers or find their own answers. Ananya, Ria, Jenna, Viswa,
I got 10, sir.
you also got 10? Okay.
I got 10.
You also got 10? Yes, Nikhil.
I got this.
You also got 10. And if anybody gets glued to the floor, then we'll have dinner with me. Okay. So here in the classroom, the epoxy that I put, that has not dried up yet. So that's why I'm asking the kids who are moving, if they get stuck, they'll have dinner with me. Yes, Ritika.
I got 10 as
You
well.
also got 10? Okay. So everybody got 10. Let me do one thing. How about Saranya? Saranya, Samriddhi,
I'm still solving it.
still solving it?
I got 10.
You also got 10? Okay. So everybody got 10. So there's nothing fancy about this one. I will do that the lamest possible way. That's what I strongly believe in. So we have to find g of, we are told that g of x is this. It goes by this. But in place of x, I have function of 1. So what I have to do is first find out what is the value of f of 1 from this equation, and then plug it here and apply this formula. So let's see what is that is coming down to. F of 1 is, let's find out f of 1 first. So f of 1 would be nothing but, I'll go by this, it becomes 5 to the power 1, which is 5. Now this says g of f of 1 minus 2. F of 1 is 5 minus 2, which gives me g of 3. I have to find out g of 3, and that is governed by this one. So g of 3 would be, in place of x I will replace that with 3. So this becomes 3 squared plus 1, which is 10. So this is a situation that you all will deal with when it comes to evaluating a function or evaluating a composite function. There is nothing fancy about it. You have to just move backward, keep knocking off the complicated things from here, keep simplifying it, and apply that rule that is given to us for solving or evaluating it. So I'm not going to talk too much about it. This is not the most interesting part of the topic that we wanted to cover. What I wanted to cover was the transformation of graph. How does the graph move? If you have a function known to you, and if you make some certain changes to the function, which way the graph goes. So that would be our agenda for today. And before I kind of start talking about that, or we try decoding that, let me give you guys some quick examples. Let's say I have f of x defined as, let's say, x squared minus 1, okay, or x squared, let's say, and that plots a graph like this for me. If I say plot other graph, which is x squared minus 1, plot other graph, which is x squared plus 1, meaning I'm saying if f of x is this, if I do x squared minus 1, or let me put it this way, f of x minus 1, what happens? If I say f of x plus 1, what happens? Which way the graph goes? What is the change that comes into play? If I do f of x minus 1, what happens? If I do f of x plus 1, what happens to this graph? Did everybody get what I'm trying to say? Okay. So again, I'm repeating myself. I have a function given as f of x, which is equal to x squared. Or if you want to still relate to it, this is how I'll describe it, which is plotting this graph. If I do f of x minus 1, what happens to this graph? If I do f of x plus 1, what happens to this graph? If I do f of x minus 1 inside the bracket, what happens to the graph? And what happens in this case? Yes.
For the first one, it goes down 1. For the second one, it goes up 1. For the third one, it goes to the right 1. And for the last one, it goes to the left 1.
Okay. I heard some answer. What is your point of view? Who in the class can tell me what happens when I do this? I mean, again, I'm going to double click on this, break it down, look at it in a most simplistic way, but yeah. Anybody who wants to give me any answer based on his or her understanding of things already? Arush, any point of view? Same as what you said? Okay. Anybody else? Vishal, Samriddhi, Ritika, Jenna, Saranya, Vivan, anybody?
Just a bit confused.
Okay. No, that makes me happy. I mean, I'm just kidding with that. So when I say that makes me happy, meaning I have an opportunity for teaching something. If you guys know everything, what would I teach? Yep. So okay, let me not bombard you guys with a lot of questions. You have a graph like this. Y equals to fx, function of x, which is equal to x squared. And you plotted that. The question is, what happens for the same graph if I, instead of doing y equal to f of x, what will happen to the graph if I'm looking at f of x minus 1? I got some answer. Yeah.
Goes down.
Mm-hmm. Okay. So I got one answer, it goes downward. Anybody in the class who want to give me some conceptual view of what exactly will happen to this one? Ritika, Saranya, Samriddhi, anybody? Nobody? Dev? Vishal? No? Okay. Alright, so the kids who know about it already, wonderful. Kids who are going to learn this along with me, let's do that. Okay. And if any of you have learned it by memorizing it, this is going to be an opportunity to decode it by yourself also. This is my coordinate plane. I have a function like this. Let me say this. y equal to x square. This is my equation. And if I have to plot in a coordinate plane, what is that I do? I will do x, y, take 3, 4 values, probably 5. What happens when x is 0? When x is 0, y is 1. But what happens when x is 1? It becomes 1 square, that is again 1. What is that I am doing? When x is 0, y is also 0. When x is 1, y is 1. When x is 2, y is 4. When x is minus 1, again minus 1 square gives me a 1. When this is minus 2 square gives me a 4. So I got 5 values. Let me try plotting it. 0, 0 is this point. 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4, minus 5. 1, 2, 3. 1, 2, 3, 4. Okay. So first point is 0, 0. This is my this point. When x is 1, y is 1. X is 1, y is 1. And we saw when x is minus 1, then also y is 1. So we are talking about this point. When x is 2, y is 4, we are talking about this point. When x is minus 2, this one is minus 4. Minus 4. We are talking about a parabola. Yeah? So this is my classic this thing of. We are talking about plotting y equals, or we are talking about what happens when I do f of x minus 1. So I am essentially talking about this f of x is nothing but my y value. Y minus 1 equal to x square. Yeah? Meaning whatever comes here is the value of x. From x, what I am blabbering right now. This is my new equation. That's what I have to plot for. Because I am trying to find out f of x minus 1. So this is y minus 1 equal to x square. That's what I am trying to plot for. So here, let's put some value x, y, 0. When x is 0, y is 1. When when x is 1, y is 2. When x is 2, it goes to the side, it gets added, so it becomes 4 plus 1, 5. When x is actually I'm doing something wrong here. Okay, let me correct myself. So this was my function or the equation. I'm trying to plot for f of x plus 1. Meaning f of x is nothing but x squared. If I'm trying to plot for f of x plus 1, I'm trying to plot for x squared plus 1. Okay? Is everybody with me so far, or I was kind of confusing everybody? Okay. So x, y. Okay. So now this is my y value for this f of x plus 1. So now look at this. When x is 0, y is 1. X is 1, y is 2. X is minus 1, this is again 1 plus 1, 2. X is 2, it becomes 4 plus 1, 5. When x is minus 2, it again becomes 4 plus 1, 5. Okay. So you should now look at this same thing. When x is 0, y is 1. So we are talking about this point. When x is 1, y is 2. When x is minus 1, again y is 2. When x is 2, it's 5. When x is minus 2, it's 5. When you join these points, what did you see? It shifted by 1 unit upward. Does it make sense or no? Jana, Saranya, Ritika, everybody, Dave, Anushka. Oh, Anushka is not here. Ananya is here only. Okay. Okay. But everybody got it right. So we had a function of y as a function of x equals x squared. And what we did, we said, okay, fine. If f of x is x squared, I want to find out what is f of x plus 1. And what we saw was everything shifted by 1 unit. So I'm not going to bore you guys with what will happen when I do a minus 1. Okay? Same table, same approach. You will f of x minus 1 will be nothing but x squared minus 1. If you are taking this as a base, and then you prepare the table, and what you will see is your whole thing shifts by 1 unit down. So this becomes a rule of thumb. That's what Davik, Arush, and some of you were saying, that when you have a non-linear function, and again we are talking more with respect to non-linear function. Okay, with linear function we know what happens, how the line moves. So anyways, I'm not talking about that right now. If we need to, we can go back to that. But what I'm trying to say here is, if you have a non-linear function, you are plotting. When you have a non-linear function, you'll end up plotting a curve, not like a straight line, like what Aranya said, right? So it will draw a curve, and whenever you do a plus or a minus to the function, it makes your graph move up or down by that many points. The whole graph shifts up or down. Let's say you have plotted with whatever equation, whatever function equation you have, or the equation you have plotted like this, and to that you want to do a plus 2, you know that okay, everything is going to move up by 2 points. If you are doing a minus 3, you know that from this place it will move below by 3 points. That's it. That is one transition or transformation of a graph that happens when you are adding or subtracting something outside the function. Is that okay so far? Everybody clear? Saranya, Riya, Vishal, Dave, everybody? Okay. Sometimes you guys can unmute yourself and say yes. That also works. Now, what will happen if I'm talking about let's say I have a function like this. What will happen when I put this? And some of you told me that when you do this, it moves this way when you do a minus, and it moves this way if you do a plus. Okay? Let's see that in the simplest possible way. Though while teaching you guys, I have kind of seen it so many times that I have memorized, but let's not trust somebody's memory. So what I will do is, we will take the same approach. Let's say f of x is plotting a graph like this for me. This is 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. Here we have 1, 2, 3, 4. Okay. Minus 1. Now we talk about f of x minus 1. So what are we talking about here? If f of x is x squared, f of x minus 1 will be what? X minus 1 squared? Yeah? Let's see how does this graph change. Meaning, I will put the value of x and y and see what happens. when x is 1, when x is 1, sorry, x is 0, 0 minus 1, 1 square. When x is 1, this became 0. So 0. When x is 2, 2 minus 1, that is 1 square. Okay. When x is minus 1, so minus 1, minus 1, minus 2, that is x is 0, this becomes 1, 1 square. When x is 1, it became 0, that is 0. When x is 2, it became 1 square. When x is minus 1, it became minus 2, that is 4. When x is minus 2, it became minus 2 minus 1, that is okay. When it's minus 2, I am seeing something going wrong here. I will borrow some help from Davik, Advik, not Advik, Vishal, whoever who can help me find out what's happening here. When x is 0, y is 1. When x is 0, y is 1. It is here. When x is 1, x is 1, y is 0. So this is here. When x is 2, y is 1. Okay, got it. When x is minus 1, y is 4. Okay, my bad. I was unnecessarily worried. When x is minus 2, then also it is minus 2 minus 3 into 9. Okay, minus 3, it is giving something 9. Okay, so let me not go to that place. Okay, yeah. I was getting confused by seeing all these little different numbers, but let's not worry about it. So what you're seeing here is, see, what did I do? I had a function y, the function of x equal to x squared. I said, okay, I want to find out what is the graph of the function for f of x minus 1. So this is my input. I'll plug in place of x. I got this. When I'm substituting these values, this is what is happening. My initial point in the first graph, original graph was 0, 0. That moved by a point. When I move to second point, I see this graph is moving. So just look at the focal point of the graph, the vertex, the lowest point. It has moved by 1 point. If you compare all these points, you will see that everything has moved by 1 unit. I mean, again, it's a hand-drawn thing, but what you can see is, when I'm doing f of x minus 1, when I'm putting a minus here, it's moving in this direction. Similarly, when you do f of x plus 1, that will be, in place of x, you will put a x plus 1, and then plot this one. You will see that everything moves by 1 unit this side. So basically the conclusion from this is, if you have any nonlinear graph, a function that is nonlinear function, and you graph it, if you do function plus or minus anything, k, plus moves it upward, minus moves it downward. If you do function of x plus or minus let's say L, it moves, a minus moves it right and plus moves it to the left direction. That's what we just saw by putting everything in the simplest form by plotting a table and then relating to that. And we saw this movement. So is everybody clear about this transformation, or I'm kind of getting you guys more confused? Ananya, Vishwa,
I get it, sir.
yep,
Yeah, it makes sense.
yep. How about Vivan? So the takeaway here is that we are not doing anything complicated here. Simple thing is, we are just trying to wrap our head around this thing, right? When I ask what happens to the transformation of the graph when I do a plus or minus outside the function versus inside the function, which way the graph moves. And here Davik and Arush in the class, they immediately jumped onto it, saying, okay, now, when you're doing a plus or minus, it moves it up or down. If you're doing a plus or minus inside the function definition, it moves it right or left or right. So for plus, it moves left, for right, it moves, for plus, it moves left, and for minus, it moves right. Is that okay with everybody?
Yes, sir.
Okay. So now I'm going to look at some of the problems, some more problems, and see if this function is relatable and can we use that for solving things related to nonlinear functions. So let me start putting some questions in front of you guys, and then we will see what is your reaction. If there is something that is not clear to you, not clear to me, we'll work on it. Okay. So let's look at some problem that I put in the WhatsApp group. And I will try not to solve this as much as I can. Okay? I have a graph like this. This is a graph of y equals f of x plus 3. Okay? This is a graph of y equals f of x plus 3. Okay? And let me put some things here for you guys so that you can use that information for solving this problem. 1, 2, 3, 4, 5. One, 2, 3, 4, 5, 6. Okay, so this graph goes like this and comes like this. Okay, so this is the graph of this one. It says for which value of x rounded to the nearest whole number must f of x equal to 0. So everybody here, this is the graph of y equal to x, y equal to f x of 3. It says for what value of x is the f of x equal to 0. This is the first problem, so I'm just giving you guys some clue here. You have been given the graph of f of x plus 3, and says find out for what value of x, f of x will be equal to 0. So now this is going to relate to what we were doing just a few minutes ago. You have a graph of f of x plus 3. You are taking 3 out of it. Whatever the original function, you are doing a minus 3 from that inside the function definition. That is how you will get a f of x, right? You have f of x plus 3. Unless you do minus 3 here, you will not get f of x. Correct? So whatever is the graph, you are going to do a -3 inside that and see how will the graph move, and then find out for what value of x the y is 0. Is the question clear to everybody or still confusing? And it's okay, guys. I mean, I can go through this again. I can repeat that again. That's okay. I'm just trying to understand if the question is clear to you all or not.
Can you repeat it, please?
Sure. So this is the, in this question it says y is equal to f of x plus 3, and that is the graph plotted here, okay, where you can see when this is 1, 2, 3, when x equal to 3, your y is equal to 1, okay, from this graph. I'm just giving you one data point here. What it says is this is your graph for this equation or this function. It says for what value of x the f of x will be equal to 0, meaning you have a graph for this. Unless you do a -3 from this, you will not get a f of x. So basically, as a step, you have to find out, okay, inside this, if I'm doing a -3, when you're doing a -3, what are you doing? You're actually moving the graph by 3 points. Okay? So it says, for what value of f, the f of x will be 3, meaning for what value of x, it will be 3, it will be 0, meaning where this will touch the x-axis. So you have to find out that point. Now, let me give you guys my brain dump. Now let me solve this like me being one among you, okay? And then it will probably make little more sense to you. So this is a question that you guys came across in the SAT exam, okay? And I am one of the SAT aspirant who is giving this exam. 1, 2, 3, 4, 5, 6. 1, 2, 3. The graph is going like okay. This is 1, 1, 2, 3. This is a graph given to me. So, okay, this is a graph. I don't know whether this translates into x square plus 4x plus 9 or if it's something else, I don't know. I have just been given this saying y is a function of x based on this rule. It says find out for what value of x, f of x will be equal to 0. So when I look at this question, the first thing that strikes me is I have a graph for f of x plus 3. This is my graph. What will be my graph for f of x? Because if I can plot that graph, then I would, and it's saying find out for what value of x will this f of x will be equal to 0, meaning where the y value of the graph that gets created for f of x will be equal to 0, meaning where it will intercept with the x-axis. So I know that, okay, if I have a graph, if I convert this to something -3, right? I have x plus 3 given. I have a graph given for this. I have to graph for f of x, meaning I have to do this as f of x plus 3 minus 3. This is what I have to do. And we know that if I have a graph given to us, if I am doing a minus, I am talking about lateral movement. -3 moves it to the right, meaning when it is touching here at origin, this will move by 3 points. So my graph will go like this. This becomes my graph. I mean, I did not do a great job with drawing, but yeah. This will become my graph. Meaning, earlier at this point, for this original graph, this is where the y value was 0. Meaning when x was 0, it was 0. But when I did a minus 3, I moved everything literally by 3 points to the right. So now this graph will touch the x-axis at this point. From 0 it moved by 3 points. So it will touch at 3 point. So when x is equal to 3. So I can clearly see for me to come from here to here, I have to get this 3 knocked off. Meaning from this graph I did a minus of 3. Meaning I moved it by right by 3 points. Meaning x which was 0 before moved to the right by 3 points. So when x is 3, this is where this graph, this new graph f of x will intersect the x-axis. Did I make decent sense? A little bit? Jana, Vishwa, Ananya? And yeah, if I did not, don't be shy. It's okay. I can do it one more time. That's my job.
Wait, so what is our final answer?
Final answer is x equal to 3.
Okay.
But again, Peter, no, don't think about the answer, okay? I'm one stupid soul on this earth who doesn't care about the answer. So I'm not wanting you to worry about the answer for now. What is important to me is how are we arriving at that? What is the approach taken? If somebody says you have a graph given to you and says find out the point where f of x is equal to 0 or 3 or 9, whatever it is. First thing that I have to look at is I have this function given, I have to find out the value of this function. Meaning from this function inside the graph, inside the bracket I have to subtract a 3. And we know when we saw that f of x is given to us, if I do a plus or minus of something, it moves the graph up or down. If I do a plus, it moves the graph up. When I do a minus, it moves the graph down. So we are not talking about something that is outside this bracket of the function. Second thing we saw was function of x minus k or plus k moves the graph this direction or this direction. If it is minus, it moves in this direction by that many units. If it's a plus, it moves on left side by that many units. So if I have to come from x plus 3 to xx, I'm talking about subtracting by minus 3. When I'm subtracting by minus 3, I'm talking about a movement on the right hand side. Everything here moves by 3 points. Earlier, my graph, in the original graph was intersecting the x and y axis at the origin. This is where it was meeting. Now this whole thing will move by 3 points to the right because we are talking about subtracting 3 from the original function inside the bracket. It will move by 3 points. So this is where my f of x or y value was 0 before, which will become at 3 points on the right. So when x is equal to 3, that is when my f of x will become 0, meaning my y value will become 0, meaning this is where it is touching the x-axis. Yeah? Were I able to beat it down to death? Ritika, Saranya, Ananya. Ananya is not convinced yet. Is that true, beta? Vishwa? I'm sorry, beta?
Can you say so?
No, I was just asking, did I explain that okay? Is it clear to you guys?
Yeah.
Okay. Vishal, Jenna, Ria, everybody? Okay. And again, these are, while this problem will look very complicated, okay? And I'll be dry honest with you guys. When I was looking at this problem, right, when I was posting the question for you guys, if you look at the WhatsApp group, I put that movement of graph towards the end. After I pasted all the questions for today's discussion, I thought I will get you guys more confused if I straight away jump onto solving this problem. That's why I said we will also talk about how does the graph move. That way, keep the phone aside. Okay. That's why I said we'll talk about first how the graph moves. Because if we are clear about that concept, this is a cakewalk. If we don't recollect what happens here, this will be a nightmare. Okay? Now let's look at another problem and see if that is relatable or not. And starting today, what I've started doing is when I'm sending you guys the video of the class, I'm also putting the link of the unit where you can do the unit test. Okay, so that you don't have to struggle to find out from where you have to do the unit test. Unit test is nothing but more like an opportunity for you guys to practice few problems based on for the concept that we are learning in the class. Okay? Let's look at one more problem and see if that is doable or not. We have time, we'll do probably two. Okay, I have another graph. -1, -2, 1, 2, 3. Okay. My graph goes from here, touches, and goes here. This is 1, 2, 3, 4. This is 1, 2, 3, 4. Okay. This is a graph of y equal to minus f of minus x. This is the graph of y equal to minus f of minus x. For which value of x is true that f of x is equal to 1. Yep.
When x is equal to -1.
Okay. So, did you guys get the question? It says this is your graph for y equal to minus of f of minus x. Yes, Dave.
Would it be 2?
I'm sorry?
Would the answer be 2?
I'll take your answer as 2, but I'm assuming that you would have put some thoughts around that one. Yes, Ananya?
I have to leave early.
Yeah, no problem. We will be wrapping up in another 5 minutes. You can leave early. But this, once I upload the video, I would want everybody to try solving this problem. Okay?
Okay.
Yeah.
Thank you.
No worries.
Bye.
Bye-bye. Okay. So, what was your answer, Davik?
When x is equal to -1.
When x is equal to -1. That is one answer. Dave is saying when x is equal to 2. The question is, this is the graph of this function, y equal to. Samanvita, you are early by 6 minutes, beta, okay? So just wait for 6 more minutes. Don't worry about the problems that we are dealing with. This is not a problem that you want to worry about. Okay, so this is the function for which we have a graph. We have been asked to find out the value of f of, we have been asked to find out the value of x for which f of x will be equal to 1. Meaning, if I decode this problem, it says find out for what value of x the y value will be equal to 1. Meaning, after you transform your graph from here to here, you have a graph for f of minus x. You are wanting to first get to the graph of f of x, see where it moves, and then you try finding out for what value of x the y value is 1. Meaning, where do you see this graph
When you put the graph -1.
being closer to 1? Yeah.
It's actually -2.
-2. Okay. Okay. Yep.
-2.
-2. Anybody else? So all the kids from level 1, hold it for 2-3 minutes and then we'll talk about it. Okay, you also got -2?
Yes, sir.
Okay. Come and take a place for yourself as if you're not here. Okay. So Vishwa, can you explain me how did you get to -2? Let's hear your story for everybody's benefit.
I was a little confused at the start.
Mm-hmm.
I don't completely get out. I was close to -1, but pretty sure it's -2.
But how did you arrive at that? That's what I'm interested in. Okay, let's hear Arush.
Okay, so for the last question, we wanted to get f of x, so last one was f of x and x plus 3, so we subtracted the 3 to get rid of 3. So this one, the problem is that x has a negative in front of it. So we multiply by negative 1, which flips the whole graph over, and if the whole graph is flipped over, what is currently negative 1 will be what we want, because when you flip it, it becomes positive 1. So currently negative 1 is negative 2, so that's next. Negative 2.
Okay. So there's a concept here of multiplying a graph with negative 1. Okay. So there are two things here that we have not talked about. When I have f of x, what will be the value of negative of f of x? That is one. We have not seen that transformation. Second thing is, if I have f of x, what will be the graph for f of negative x? That also we have not looked at. So I will assume whatever you guys have found by now is right, but then I still owe you guys how to describe, how to interpret the transformation of the graph when you multiply with a minus outside versus you multiply with a coefficient of -1 inside the bracket for the variable. And this is what I would not try to rush through in 2 minutes that we have. So I will let you guys grapple with it, and I'll explain that in the next class, and then we'll do few more problems before we move on to next topic. Is that okay, everybody? Okay.
Yes,
With,
sir.
with that being said, I'll let you guys go. Enjoy the rest of your evening. My torture for this week is over. See you guys on Wednesday, whoever are there in the recalculus class, or whoever is there in the algebra 2 class. Otherwise, see you on next Saturday. Alright. Yep. Bye bye.
Bye, sir.
Bye bye. Bye bye.
Are you